In this module, you'll learn how to test Leo programs. It's required to build resilient applications. To actually test your Aleo programs, you can use the testnet network directly, but that is not the most efficient way possible. The reason is you would need, every time you redeploy a program or run a transition, you would need to have Aleo testnet credits, use the faucet a lot, and also it will take time for the transaction to actually get on the network. So what you can do instead is use a devnet network locally, and that way you can test your execution and of the on-chain part of the functions and see how the mapping value changes. So I will need to move to my SnarkOS folder that I have locally. And here I will list the files and see that I have my devnet.sh bash file. I can simply run that. So the default number of validator is 4. I will let it like that. The number of clients is 2. I will run it on testnet. I will say actually no to recompiling, to rebuild the binary, and I will clear the existing ledger history. So here, let's be quick and move here by clicking on Control B and then 1. And I can copy here my private key for my validator on my public key, my address. It should be the same by default for you right here. So now that my devnet is supposed to be running, if you go to that endpoint right here, you can see that we have already produced 4 blocks. Okay, so we have 4 blocks, and that validator here should be filled with Aleo credits. So let's go see what is the balance of that account. So it's the program credits.aleo endpoint. We'll get the mapping value for the account mapping, and the key will be that. And as you can see, I got plenty of Aleo. So in order to know how many Aleo I have, this is the balance in U64. There are 6 digits actually. So 1, 2, 3, 1, 2, 3 here. So I have 18 million, about 19 million Aleo credits. So that should be more than enough to actually deploy programs and make transactions. Okay, so now I have my devnet running locally. You should know that there is a solution provided by the community in order to run these devnets locally that consumes less of resources. So you can, I will open it here. This tool is actually a lightweight version of that devnet. It is way much lighter, and it is actually the exact same purpose. It's light, it has less clients, so you could use it as well. So just check out the repository if devnet bash here is too heavy for your machine. And if you want to kill the devnet, you can just simply do Control B, then dot, and then kill session, and then press enter. I will not do this here, but yeah, that's how you do it. Okay, so now we have our devnet running. We can actually, for testing purposes, in next chapter, run the Aleoscan Explorer. So now that we have our devnet running, we can access all the blockchain data using directly the endpoints from the client that is running in the background. But actually, we don't want to just do that, because for debugging why a program would have failed, for instance, when the on-chain execution would revert, for instance, when there is an assert that is false, or when there is an operation that overflows, we want to actually know what happened, where the problem is, and so we don't know using those tools where there were failed. So the way we can do that actually, and the approach that is proposed in this course, is to actually run the Aleoscan Explorer locally on your machine. So actually the Aleo Explorer is open source on GitHub, and you can run it on your machine. So the way you can do that is very simply using Docker. So you would just GitHub pull that repository, and then once you have it, you can just docker compose up -d, and then it would just be up and running. So this is exactly what I did. So let me just run those containers, and I actually filled with a few transactions my blockchain. So let's just go to localhost 8800. So it's still syncing with my node. And so what actually this Explorer does is it fills a database, a local Postgres database with blockchain data. So every time we want to know, for instance, all the program that there is on chain, it doesn't require to go through every transaction, but it's synced inside of a database. And it also has a front end for representing that database. So it is pretty useful. I deployed a bunch of programs. And then I wanted to show you how I can use that to debug my actual program. So when I open any program, like this one here, I can see the list of transactions that were called. Let's go to one that failed, so you can know, how I can use it to debug which instruction failed. Okay, so here I got NFT program, and at some point there is a transaction that gets rejected. So in order to understand what happened, what was wrong, we can see that the rejection was for this transaction. So let's just go to the right transaction, this one here. And as you can see here, we get the exact problem of why the transaction was rejected. So it tells me that the key of the mapping was not found in some of the mapping in transition 0 and at exactly this instruction. So when there is an assert that is false, it will give you the instruction as well, where the assert is false, and it would give you the values that the assert failed on. So here for this transaction, it's pretty useful because we know exactly which transition failed. So here we have two transitions in that function, and it tells us that it's at transition 0 that failed. So let's see where in the transition there was a problem earlier. So let's just copy that instruction right here, and we'll go inside of the transition 0 here. And so this transition is for a certain program ID that we have right there. And if we go to that program ID, to the source code of that program, I can actually find the instruction that was the problem. And that way, I know exactly what is the key I'm trying to find. And I can actually read the mapping, either using this right here, or directly using that right here, my API, RPC API, to get what is the actual correct key for the mapping value and what is at the key that I was trying to find. So you can actually, what is very also useful about this is that you can actually, for any transaction, let's say this one, see all the mapping operations in your program. So you know that this mapping here at that key here was created with this value right here. And when there is a mapping value that was deleted, when there is an account that changed, here it's for the fees, for instance, everything is right here. And you actually just need that to debug your programs in a very, very useful way, completely locally. So this is why this Explorer is amazing, and I really recommend you looking into it. There is another very useful community tool that is provided by Venture 23, building on Aleo. It is a DokoJS library, which is an interesting library to actually test and use your programs. So you actually use it, you must download it first using npm, so you can install it globally using that npm command right there. You can also build it from source. And then the usage is you can use it directly from your terminal. And you can actually initiate a project using the Doko command line. The idea is that this tool is pretty flexible. You can actually come up with your own scripts. And you put all your programs in the program directory here, all your source. And when you type in compile, so you just add the programs inside the program directory using the DokoJS add function along with the program name. And once you have added your programs and you type in DokoJS compile, it will create a folder that will contain a JS conversion of the Leo function. And actually, so those JS conversion in TypeScript in particular will contain all the transition and mappings from the program. And this is the way Doko is useful to actually test the program. So once you have done that, you can simply use npm run test command. If you want to run a particular test, you just enter the name of the test file. And that way you can actually test on a file that was generated in TypeScript. So you don't test actually your Leo program, but a conversion of your program into TypeScript. It also provides a lot of interfaces, so you can actually get data from your program directly. Here are a few examples. So I would advise you to look into the repository to see how it works. But basically, you just write your unit tests. Here you start with this describe here and just write all your tests with the name of the test, and then you provide what you want to test. If you want some value to be a certain value, you can here get the mapping, for instance. So the way it is built is that you call the describe function here. Then you have all your unit tests inside of it. Inside of your test, you can call those TypeScript functions. Then once those TypeScript function has been called, you can actually do your unit checks here. So my advice is just look into it. The Probable team recently published a new tool, the Leo debug function in the Leo command line interpreter, that will help builders to actually debug their programs. So in order to test that, we will go into the token, simple token that we did in a previous chapter. So let's just move into it in our command line. And from here, from this context, we can run the Leo debug tool. So the Leo debug tool will allow you, so it's a REPL, so it will allow you to put any command that you would have, any instruction you would have in Aleo, for instance, a sum of 2u8, and as you can see, it will interpret it and give you the results. So this is very useful for learning Leo, and also you can use it to actually debug. So how do you actually use it? Well, actually, because you're in the context of your program, you can actually call any transition. For instance, my get metadata transition from here, I would first put the program ID here. And then let's just call my metadata function. And as you can see, it's returning here the right metadata. So you can actually use it to get the return value for a function. So that's the base use case, but that's not all. You can also go through every line of a program and go evaluate that statement. The interpreter also provides some comments, which allows you to go step by step into every expression, for instance, using the watch and then expression command. You can then go into each next step by just running the step command. Then you have the run function that will allow you to go to the end of the execution. And basically, you can use all those commands to go through your program and evaluate at any point in time all the variables in the program. So let's say you use the break function to go to a certain line of the program by adding the program name and then the line number. You can then look into what some variable is at that point in time in the program. This is a very powerful tool to debug. So there is also a few helpers, cheat codes, as it's called here. Basically, there is a cheat code print mapping along with the mapping name as an input, which will print the current mapping and its states. And there is also the set block height, which allows you to set a certain block height inside of your program. So I highly recommend looking into it. It's one of the most powerful tools that there are out there in order to actually evaluate instructions. In that future, it's really, really powerful. You now have no longer excuses for having bugs in your Leo programs. See you in next module for the final assignment.